Alright guys, so here is another example video dealing with solving non-linear systems. Okay, so we have done these videos in the past, right, where we solved non-linear systems using both substitution and elimination. So be sure to go ahead and check out those videos before trying this one. Okay, so getting right into this problem, why don't we go ahead and talk about it. So we know right here, right, this is going to be an equation of an ellipse. Okay. Here I have an equation of a hyperbola, right? So at most here, if I have my ellipse, right, and then I have a hyperbola, right, at most I can have 4 solutions or 4 points of intersection, right? Which is going to occur here, 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 and here, right? 4 points of intersection. So at most here I can have 4 solutions, all right? So just keep that in mind while you're doing this problem. Now, looking at this problem, what makes the most sense here? Should we do elimination or substitution? Okay, and looking at it, well, look at my y squared here and my y squared here, right? I have a plus 9y squared and a minus 9y squared, right? That will simply just cancel out and just leave us with the x squared, and that's what we want, right? So when we are using elimination, we're trying to cross out a variable so we can solve for another, right? And this one works out nicely, where this is just going to be simply cross out. Okay, so why don't we go ahead and use elimination? And all we're simply going to do here is add, right? So we're going to do 25x squared plus 16x squared. That's going to give us 41, right? X squared. Right here, we just talked about this, right? A positive 9y squared and a minus 9y squared. Well, that simply just cancels out, so we don't have to write it. Then we have equals, right? And we have 225, right, plus 144. So again, we'll have the following here. We're going to have 3, 6, 9, right? And then we're simply just going to divide both sides by 41. So 369 divided by 41, and we get 9 here. Okay, so we get 9. So let's go ahead and do that. So divide by 41, divide by 41. We get x squared equal to 9. Take the square root on both sides, right? X will equal plus or minus 3. Okay, so we just found the x value, right, or values, right, plus 3, minus 3 of, okay, our solution. Right, so why don't we go ahead now and take this, or these x values, and plug them back into one of the original. Okay, so let's go ahead and erase this. We know that x equals plus or minus 3. And essentially we're just going to plug this in and solve for y. So we can get the y variable of our solution, right? So let's go ahead and plug in a positive 3 first. So we'll get the following here. We're going to get 25, right? And we get 3 squared plus 9y squared equal to 25, right? I'm just plugging it into that first equation. So if we do 3 squared here, we know we're going to get 9. So we get 25, right, times 9 plus 9y squared equal to 225. Okay, so let's go ahead and do 25 times 9. So if we get 25 times 9 here, we get 225. Okay, so we're going to get 225 plus 9y squared equal to 225, right? Well, we're simply just going to subtract 225 on both sides. Okay, and you can probably see how this problem is going to work out. We're going to get 9y squared equal to 0, right? Divide both sides by 9. You get y squared equal to 0. Take the square root on both sides. Y will just equal 0. So what happened here? Well, I plugged in a 3, right? So I plugged in a 3, and I returned a 0. Okay, so this point right here is one of my points of intersection, or one of my solutions, right? Okay. Now let's do it for negative 3, right? So we're going to do the same thing now for negative 3. Now, think about this here, right? If I take a negative 3, I plug it back in to where I had this 3, right? Here's my x. Is anything going to change, right? I'll just have negative 3 here. We know that anything, whether it be positive or negative, when it's squared, right, will always be positive. So if I put a negative 3 here and I square it, right, it's still going to give me 9. So the result is going to be the same answer here. So what you're going to get here is, when I plugged in a negative 3, I also got a 0. So this right here is going to be your solution. So this is going to be the point of intersection at 3, 0 and negative 3, 0. So again, this is your solution here. Okay, And that is it.